All right, folks, thank you for joining us for our first honors colloquium after spring break. We are very excited to have a presentation by one of our own honors students. Marcos Revilla is over here. You might not be able to see him on camera right now, one of our electrical engineering students. And he is going to be speaking to us today on how to buy a truck, a new way to find a deal, which I think was a project you worked with Dr. Ralph on. Is that right? All right, well, come on up and I will mostly get out of your way.
Alrighty.
I can advance your slides if that's easier.
Sure.
Okay, I have a purpose. Excellent.
Alrighty. So this project here is what I did over last semester with Dr. Ralph. I did it concurrently with my probability course. So if you want to go ahead and
Yeah,
to the
sure.
next slide.
There we go.
All right. So whenever we think about buying a vehicle, the market is going largely to online. So whenever you look at a car online, you see the pictures of it, you see the mileage of it, and you don't get the same experience as what you do whenever you're in person. So whenever you go to buy a car, you consider the probability of that being the good car, the car that you need, because you have a certain amount of expectation. So are you going to use this truck to go back and forth to the supermarket? Are you going to use this truck to carry stuff? So all those things you consider whenever you're buying a car.
Okay.
So the traditional car buying is you go to the dealership, you have a test drive, you can walk around the car, get a feel for it, look at everything about it. So the big thing is the shift in the market with Carvana, places like that online. So you don't get the same kind of experience. So it's harder to necessarily predict what is a good car for you, you know, just because you can't look at under the hood, look at the engine, look at anything else. So go ahead.
Okay.
All right, so we want to introduce engine hours. So engine hours is a lesser known parameter, and this is what my argument is on this project. So engine hours are more common on like equipment, like lawnmowers, boats, semi trucks. So this picture here is out of a Peterbilt tow truck. If you can see right here, it's kind of hard to see. That's the engine hours. That basically shows exactly how long the engine's been running. So whenever you crank your vehicle, the timer keeps going. So it's different from mileage. So mileage is only whenever you're moving. Engine hours is whenever the car is running. And so I will also specify that the title of this presentation is how to buy a truck. So the difference in how to buy a truck and how to buy a car is trucks. What I found is typically has engine hours. So whenever I started this project, I was trying to do this as how to buy a car. So whenever I went and did some searching, I could not find any small family sedans or anything like that with engine hours. So I shifted this to how to buy a truck. So if you look right here, this is the mileage and that's the hours. So if you divide those two, you get 19.5 miles per hour average. Now I'll explain that more in detail a little bit later, but just for reference, this is like a heavy equipment kind of thing, you know, big truck. And it's not similar to like a regular road going car. Okay, so this is where I considered probability. So I took data and I modeled it along the Gaussian curve. So what a Gaussian curve is basically how to represent data in like a normal fashion. So if you look right in the center, that's the average. So the average is where most of the data will lie. So the way to describe a normal curve is with the average and the standard deviation. So with standard deviation, there's plus and minus 3 standard deviations. So within the first standard deviation, there will be 68% of your data. So that's the most common, most normal range of acceptable data. Go ahead.
Yeah, sure.
So what I did is I went out and went to several car dealerships, mechanic shops, and got a pool of data. This is a snippet of my data. And I used this to model along the Gaussian curve. So I took the mileage and hours and I listed the year, make, and model of the vehicle. And what I did is I found the average speed of it. So what the average speed is basically taking your mileage from the vehicle and the engine hours, and you divide them. So if you do that, you get an average miles per hour. So this represents how often or how fast the car speed of the truck tends to move. So a truck with a higher mile per hour has been used more on the highway, and one that has a lower mile per hour has been sitting around idling, working, whatever else. So, this was a plot of my results. So I found that the average mile per hour is 31.8 and around 32. So if you go out and buy a car and you look and it's about 32, that's what it, that's the normal, that's about average. So the standard deviation of this data was 5 miles per hour. So I would say the acceptable range whenever you buy a truck is between 27 and 37, with a better truck tending to be a higher speed, average speed, because it's been used more on the highway. All right, so what does this mean, having a higher miles per hour, higher average speed? So this is my big claim on why this is important. So having a higher speed, average speed, this relates directly to the lifespan of your vehicle. So most people have heard to change your oil every 3,000 to 5,000 miles. Well, if it's a truck, like say a construction truck that's just used for work only, most of the time those trucks will sit around at the construction site and they'll just sit there and run and run and run, and they won't ever be used. But whenever they go to sell them, they'll only have like 130,000 miles or so, which isn't terrible. But if it has a crazy amount of engine hours, it's not as good of a truck as it is that's one that's 130,000 miles with a lower engine hours. So this is what it could look like with a prolonged oil change. There's a lot of oil buildup. That's all really black. It's supposed to be clean. And whenever you have a truck that's idling more often, it's less likely that the oil is going to be changed on time. Because even if people still do it on a regular mileage interval, the usage will be a lot higher. So the engine will be running more than a regular truck used on the highway for 3,000 miles. So the argument here is to change oil more on a time basis, like every 6 months or so, instead of every like 5,000 miles. This also, beyond engine wear, you have regular wear in your truck. Whenever it's sitting around idling, there's been more time that people are sitting in it, tearing it up, that kind of thing. So one that has lower engine hours is usually a little more taken care of, Go ahead. All right, so say you have a low average speed vehicle. What does this mean? It's most likely to be a construction or a work truck. So out of my data pool, I went out to test my claim that a vehicle with a lower average speed would be more likely to be a construction style truck. So I went out and I got one sample to add into my list, and it was about 27 trucks total. So I added one construction truck and just at random, and it had the worst average speed out of all of my data pool, because everything else was from car lots, pre-owned. And the average speed of that truck was like 22.6 miles per hour, which is relatively low compared to the average of 32. 32. So that kind of shows that construction trucks are typically a little more abused and left running more often than a regular road going car. The solution to this is mainly having less unnecessary idling. So like whenever you're sitting somewhere, like at home, and you're waiting on somebody, just go ahead and kill the truck, whatever it is, instead of just letting it sit there and idle. And another solution to it, like I said, is like changing the oil on a time basis rather than the mileage basis. Because if you change it on a time basis, it won't matter regardless of how many engine hours you have. It's a regular oil change. All right, I also considered my project and what limitations there were in what I was finding. And the biggest limitation is about the data pool size. It's kind of hard to get the data from this because you have to manually go out to the car lots, and not everybody's on board with you walking around with keys to cars and looking at it. So whenever you look for engine hours, it's usually just on the odometer where it shows your mileage, the little button that cycles through. You just press it and it'll show on there at some point on a truck. So whenever I go out to car lots, I have to get like keys from everybody, the whole process. Not everybody's completely willing, so a big limitation is just the size of it. Another interesting thing to see on a concrete number of like what the normal average speed is for a vehicle would be comparing it to trends with different vehicles. So say certain trucks tend to have more engine, a lower average speed or a higher average speed, and whether it affects it more than another truck. And the biggest limitation to it is human exceptions. So a truck can be used and only have like 100,000 miles and have an excellent average speed of, I don't know, 40, and still be beat up from human exception because they just don't care about the truck. They just beat it up, you know? That'll be largely a human exception to it. Next one. So the goal of this is mainly to show what to look for whenever you're buying a truck. So the main takeaway in this is whenever you're looking at a truck, you not only consider the appearance, the mileage, how it feels, you also consider the engine hours and how much wear that vehicle might have. So whenever you do that, the equation I use here is the main takeaway I want to show in this, that you can calculate your average speed of your truck by just taking the mileage and divide it by the engine hours. And if it's within 27 to 37, I would say it's acceptable. If it's more than 37, it might be a better off, but it's hard to say because a lot of things, human exceptions, you know. Whenever people are driving long distances, that's usually whenever it gets over 37. A lot of times those get beat up as well. The lower end of that is typically worse off just because it's been sitting around idling, as we mentioned. And another takeaway from this is the push for more data collection. So if this research was done a little bit more, maybe it'll be a little more useful among different brands and stuff. So say you have like Kelley Blue Book and you look up the value of your truck. So if Kelley Blue Book or a bigger company did like research about this, they would be more accurate in their vehicle estimations on what the vehicle is worth based on entering the engine hours as well as mileage. And another thing about it is the push for more information online. So whenever I started this project, I looked at Carvana and different places, and I tried to get my data pulled from there to see if I could just get the engine hours directly from the website. But engine hours is not a parameter that most used car websites offer. So you can't even find it on there. So it's mainly like an in-person thing where you can see this kind of thing, where you can look at the car, get the engine hours, and figure out your average speed. So if it was offered on the website, it would be more useful to the consumer. Last one. And this is a list of everybody that's helped me along the way. Dr. Ralph is who I did this project alongside. He helped me with the Gaussian curve and showing the data in that way. Everyone else, Divers Motors, Coleman Chevrolet, Smith Macon, Nissan, Car-Mart, those were the main car lots that let me come out and get most of my data full. And then I also went to different shops to try to get a few bits of data. That was Precision Paint and Body, Blue Gorilla Garage, and Shelby Service.
Okay. All right, let's say thank you first with an applause. Well done. Now we can enter into the discussion phase of our little presentation. So I'll let others ask. I have a few questions myself, but anyone out there want to ask, or Mohammed, Kenny, you can jump in. Yeah.
So just out of curiosity, why don't cars have engine hours?
I don't know. It's weird. I'm not really certain why manufacturers choose not to use it. So my idea about it is that cars are more typically in-town drivers, because there is a thing on certain Chevrolets that they have average speed setting on the odometer. So you can cycle through and see the average speed. And if it's accurate based on how I do this, then it's really low, because the one I looked at was like 17, 19, something like that. It's horrendously low compared to a truck.
Caitlin, then sir.
How many need in order to get like a really confident set of data?
As many as possible. It's hard to put a solid number on something like that. Usually with data, it's just as many as possible is the best thing. The more you get, the better your data is. So I could say a few thousand, but if it was a few 100,000, that'd be even better, you know. There's a bunch of cars on the road.
Sarah.
I have a Volkswagen. I know I have time on there, but I don't know if it actually has the average.
Yeah.
I would have to look, but now I'm curious. I want to go
Yeah.
check and see.
Yeah. So certain cars, I know Chevrolets are the most transparent and easiest to find engine hours on. So like Fords, they were quite difficult to find engine hours on. You just kind of have to know how to get it. But Chevys, you can just cycle through and you'll see it immediately from any truck 2003 and up. They all have them. And that goes as Tahoes as well.
You think car companies like on their websites hide that on purpose or?
I would think so. I would say that just because it's in the trucks and not the cars, they know like there has to be a certain reason why they don't include it in cars, just because they don't want it to be known.
Yeah, no, I mean, I've always remembered back in the old days, they would differentiate between city miles and highway miles. When they were trying to get money out of you. They'd say, well, these are mostly highway miles.
Yeah, and even whenever you go to buy from a person,
They're lying.
they're lying.
Even if they're not, I mean, it's, if it's the person who used it to commute back and forth to work on Interstate 30 versus driving around the city.
Yeah. So this is more of a concrete way to argue with somebody that's selling a truck that says it's all highway miles and trying to get an absurd amount of money out of it. And you get like a figure of 22 miles per hour and be like, this is crap. It's not, it is not highway miles. It's in town trying to sell something that's not right.
I guess that's my question. It's sort of the flip side of, so I guess we understand why the cars don't include it, though you can cycle through and, get your average speed sometimes.
Yeah.
Why was it ever included on trucks then, do you think?
It's
What was
more
their
common.
approach,
So I work for Verizon on the road doing GPS trackers and cameras on fleet vehicles like semis, tow trucks, everything of the sort.
Sure.
And that's where I got this idea, and that's where that picture came from. It was one that I took that I was showing the engine hours on.
Yeah.
So all of the heavy trucks, like semi trucks, they all include engine hours. And that's mainly to show the usage of it. So whenever I did this, I also took a cement truck into consideration, and they have to run constantly to have the drum turning. And it was only getting 11 miles per hour comparatively. So that's why I say this one was 19 and a half, and it was like a tow truck. So,
Yeah. I wonder if this was driven by corporate, I mean, because like the people who are usually buying these sorts of trucks tend to be companies,
yeah.
and they can leverage a lot more, I guess, influence than your average individual consumer. So I wonder if they pushed for this 20 years ago to be included, and that's why it's not on cars.
Most likely. And it's very common on like boats and lawnmowers because you can't really show a mileage. It's just whenever it's running. So
Well, like semis, a lot of those guys, like if they're long distance, that thing's running all night long when they sleep, all of that. It's not even just, I mean, it's pretty much running all the time.
yeah, and that's what I was considering. There's a few long haul trucks I took data from, and they were still among like 40 or a little bit less than 40. So I was expecting them to honestly be about 60 or so, but they just weren't.
Wow.
Have you thought about maybe making some kind of device to verify the time that the engine's running? Because I know there are things that Volkswagen's been doing, and there's a couple brands that have been caught basically fudging the internal sensor and what it says for your gas mileage. So.
Yeah, I haven't considered like making that like an aftermarket thing to add on for something that doesn't have it, but it's mainly a thing of where it have to be added on like close to it being new. So one of my data points was from the owner of Coleman Chevrolet, his personal truck, and it was like one of the highest engine hour mile per hour ratio on there, and it had very low miles on it. So that's like the critical point where engine hours can go the change in engine hours and mileage will be more significant because there's more life left in the vehicle where it can change. So if it was done early, sure, that could definitely be possible.
Yeah, good question.
So this kind of rings a bell for me. Back when speaking about military or government vehicles, a lot of times they're operated at very low speeds, especially if they're used as a work truck, because a lot of times on base or flight line speeds will be either 15 or 25. And a lot of times when you had vehicles that were ran at that speed for long periods of time, they've run real poorly, they start to sputter and they spew smoke all
Yeah.
the time. And the fix that they would tell you is to take it on the highway and run it 80 or 100 miles an hour until it stops.
Yeah, exactly. Whenever a vehicle gets higher in its RPM band, it oils it a little bit better, so it goes full pressure. So like on my GMC Sierra, whenever it's idling, it'll get like 25 pounds of oil pressure. Whenever it's going down the road, it'll get like 40 pounds, and that's better lubrication to your engine.
I mean, from my, just eyeballing it, your data looks to be like it would be really accurate and it would add some reliability to buying a truck, especially if you want it to be a work truck.
Yeah, for sure.
Don't ever buy a government vehicle.
Yeah, that's what I'm saying as well. So like, the main goal is like to differentiate like a construction truck out of like a pool of trucks that get into the regular consumer car market, because companies will sell their old trucks whenever they get new ones. And that's what I do for Verizon. Whenever they get new ones, they get ones taken out and swapped in. And a lot of times the person that's buying it will be there whenever I take it out. So they can see that it's a truck that only has 130,000 miles, but they don't consider that it's been only going like 15.5 miles per hour average. So it's more like a 220,000 mile truck per se.
I would imagine this data point, hours is on these trucks because the manufacturers know that there's a significant difference in between the miles and the engine hours, and that's why it's there.
Yeah.
People want it.
I also assume it's there for work trucks because businesses would think about it, but they're like,
Yeah.
Consumers don't need to
Yeah.
care. Well, you get in pickup trucks, you said. which is
Yeah,
interesting.
and what you were saying with like companies wanting to know that, I was thinking alongside that, that's a good point, because if you have like a cement truck or a tow truck, those trucks can have the PTOs and whatever, the power takeoff, the drum or whatever taken off and sold as just a truck and frame. And you don't know what it was before, so how do you distinguish the value of that truck?
Right.
Mileage is kind of whatever. Those trucks go a million miles or so.
Yeah, oh, that's interesting. Any other questions, comments? Recriminations? No? Okay. In that case, let's go say thank you again to Mark. Oh, wait, Kenny, did you have a question?
Yeah, I do have one kind of comment. Excellent presentation, Marcos. Excellent. Yeah, I'm going to go home and now try it on my truck because I had never thought about this before. This is excellent. I will give you a little sidelight just to Marcos and those folks in the room. I'm glad you got the car dealerships to cooperate with you. One thing I've learned, personal experience, and I was not ugly at all, but there was one used car dealership in town. I was looking for a car for my daughter. I went and looked the car over, took it for a test drive, come back and asked the guy a bunch of questions. And all of a sudden he looked at me and says, "What do you do for a living?" I said, "I'm a licensed engineer in Arkansas, Texas. I teach engineering at A&M. He said, "Okay, thank you." Didn't want to talk to me anymore. So we're too analytical. Our critical thinking skills are too much sometimes for car dealerships. We introduce this kind of stuff, but this is the kind of stuff we need to be thinking about. So good job.
Yeah, the great part of this is you don't have to have mechanical knowledge to be able to argue with somebody over like the value of it. You can just like divide this number by this number, and boom, you have an argument there.
That's good. This is a good tool in the right.
Being able to
The
haggle.
eternal war against used car dealers. Yeah. Awesome. Any other comments or questions? All right, in that case, let's say thank you to Marcos one more time. Well done. And hopefully this will save you some money when next you buy a truck, possibly a car, depending on how you possibly. All right.